Okay, so let's go to couples, and this one is just an extra topic. So it's the same concept as your moment, but the idea of couples is that you have two forces that are equal, so meaning they create the same magnitude for the moment. And thus, since they have equal amounts of forces and they are creating the same moments, so the resultant moment from the center is equal to 0. So what do I mean by this? So for example, I put my moment here. So moment about O. So let's say this is point O. So if I try to solve for the moment at point O, so notice that the distance, so this one becomes d over 2. And then the other distance is also d over 2. So if I'm going to solve for the moment of both forces, so this becomes, one is the same direction as the other, diba? So it will cancel out each other since they are the same force, diba? Or they will double up the value of the moment if you take moment about a certain location aside from point 0. So usually the value of the moment will depend on the location of your moment center. Okay, so if you read the red part here, so it is evident that the magnitude of the resultant of these two forces is 0. So why 0? So again, one is going in this direction, and then the other is going on the opposite direction, which cancels out the forces, diba? So for example, if it's not in the diagonal aspect, so for example, this one is in horizontal um, orientation. So for example, you have a 10 kilonewton force going to the right, then you have a 10 kilonewton force going to the left. So we can say that if we sum up forces horizontally, so the resultant of these two forces is 0, diba? So muna siya. So this one is just a diagram. So at any given orientation or any given line of action, as long as as long as the forces that are opposite each other are the same magnitude, so they are called a couple, and they cancel out each other, thus resulting to a resultant force of 0. So their moment sum is constant and independent of the moment center. So again, if you try to take moment about this one, so it's constant because if you take moment about here, it's the same value as going downwards, diba? So it's still, so moment about point O is f times d over 2, and then plus f times d over 2. So that's the same. So if you take moment about A, so force times the distance only. So notice that the value of the moment from point O is just equal to the moment at point A. So thus the first statement is correct, that the moment sum is constant. So if we add the moment about O, so f times d over 2 plus f times d over 2, so it will give us f times d. So same goes for moment about point A. So if you take moment about point B, so I think it's a different story. So you need to add up another distance A because that will govern the distance of your force going to the left, and then your force going to the right will be governed by A plus D distance. So again, if you try to write it, so this becomes F. So since it's counterclockwise, so F times A, so that's counterclockwise, so I think it's positive, diba? Most likely the first two terms are negative because it's rotating clockwise. And then the other distance is minus. So since the moment, the upper force will create a moment of minus F times A plus D. So again, if you try to expand this one, so we have positive F times A, then minus F times A, then minus F times D. So notice that the moment is still constant. The value of the moment is still constant, which is negative F times D. About the same siya, the moment about A, and then the moment about B. And also the moment about O. So it's still negative F times D, because again, if we try to combine this one, F times D over 2 times D over 2. So this gives us negative F times the distance. Okay. So let's try to go with the other description or definition. So the couple is independent of the moment center. So thus the effect is unchanged in the following condition. So the couple is rotated through any angle in its plane. Then the couple is shifted to any other position in its plane. So meaning you can represent your couple in the other position as long as it's on the same plane. And then the couple is shifted to a parallel plane. So another plane, so meaning you are finding its equivalent. So in a case where a system is composed entirely of couples in the same plane or parallel planes, the resultant is a couple whose magnitude is the algebraic sum of the original couples. So the resultant is a couple whose resultant is the magnitude whose magnitude is the algebraic sum of the original couples. So we'll be using this term later once we go to the example. So you're going to use moment about a certain point, but what we are dealing now are couples or forces in opposite direction and equal magnitude. So for example, the same line of action but opposite in direction. So tan, or we're going to have horizontal forces left and then the other one is right. So let's say 20, 20, or you have diagonal forces, say 30. So as long as they are opposite in direction and they have the same magnitude, but the same line of action, so they are couples. So mura na siyang new thing. So you can still apply what we have discussed from the previous meeting, katong moment of a resultant force system. So important note to remember, so a couple is made up of two equal parallel but opposite in direction. Okay, opposite in directed forces or direction. So this is what I have told you earlier. Okay, so the perpendicular distance between the action lines of the forces is called the moment arm of the couple. So this one is still the same concept as the moment. So force times the moment arm. So the magnitude of the resultant of these two forces is equal to 0. So what do you mean by the magnitude of the resultant of the two forces? So meaning it could be summation forces vertical equal to 0 or summation forces horizontal is equal to 0 depending on the direction of your couple forces. So fourth one is their moment sum is constant. So as what I showed you earlier, so the moment of O and the moment about A, the moment about point B is the same. So it's constant and it's independent of the moment center. So meaning Kung asa pa na siya nga kuan na moment center ang inyong gi-refer to, or if you refer to a different location for your moment center, so the value of your moment sum is always the same. So that's why it's constant, regardless of the location of your moment center. So that's why it's independent. So at any location, so sagasa pa siya ibutang inyong moment center, the value of the moment sum is still the same. That's why it's constant. So the moment of a couple C, so meaning that's the moment of the couple, that's called C. Or let's say if you want to represent it in a mathematical manner, so that's M sub C, the moment about the couple. So it's equal to the product of one of the forces composing the couple multiplied by the perpendicular distance between their action lines. So for example, this is the force, and then this is the distance, perpendicular distance between the two couples. So it's just a force. So since these are equal of magnitude, so the moment is just force times the perpendicular distance between their action lines. So between, so meaning at the center of the distance. Okay, so that's the force times the perpendicular distance. So let's say d over 2, or say this one is d. Force times distance. Okay, so let's go to example number 1. So a couple consists of two vertical forces, 60 pounds each. One force acts up through A, so meaning at point A, so the 60-pound force is acting upward, and then the other acts down through D, so meaning at point D, so this one is pointing downwards. So both are 60 pounds. So transform the couple into an equivalent couple having horizontal forces acting through E and F. So meaning we're going to convert your up and down forces at point A and D to a horizontal force acting through points E and F. So let's say we assume that this one at point E, the force is going to the right, then at point F, the force is going to the left. Okay, so this is just a 3D view. So if we try to put it in the 2D plane, let's say this is the front view. So this is point D, this is point E, this is point F, and then point C. So these are the couple forces that we need to determine. So this is the 60-pound force going downwards in point T. So point T is on the other side, diba? Which we cannot see because we are in the front view of the object. Okay, so what do we need to do here is we're going to take moment at a certain location. So let's say moment about point E. So moment about point E. So again, the moment is just the perpendicular distance from a certain point times the distance going to the force. So you have 60. So 60 times, so that will be 4 inches. Okay, so this is the perpendicular arm of the D force. The rotation is positive clockwise, diba? Positive value since it's counterclockwise there. So it's counterclockwise. Okay, so next is your point F. So F here. So plus, it could be minus there. It's minus. So that will be the, let's say it's F sub C. So that will be times 3 inches. Okay, so since the moment is equivalent, so meaning this one should be 0, the moment about point E should be equal to 0. Because again, what we are trying to find out is the equivalent couple of 60 must be converted into this aspect, which is the horizontal condition. So from vertical at points A and B, so it becomes the equivalent of horizontal at point E and F. So meaning if we try to get the moments of the two couples, so it should be equal to 0. Okay, so meaning 0 is equal to 60 times 4 equal to minus F sub C times 3 inches. Meaning F sub C is equal to 60 times 4 divided by 3. So F sub C is equal to, this will be 20. So 20 times 4 will be 80. 80 pounds. So this will be 80. So automatically the other force will be 80 as well. So they may not be the same in magnitude, but if you try to solve um, the moment about a certain location, so both will be of equal magnitude. So why did we not include the other 60 in the taking of the moments? So again, if we take up the 60 moment, so madouble lang ato ang moment since both are a couple man, diba? So it won't matter if we're going to choose just one because the moment of both are the same, diba? As what we have mentioned in the previous slide. So that's why we're only taking 160-pound force. And another is another one force on the horizontal aspect. Okay? So sige lang, ini ka exam siguro. So I think I'll just give you what I have discussed in the examples and also in the assignment. Just try to review those items, and what I'm going to do is I'll just change the data. So ako lang i-manipulate ang data, but at least once you answer the exam, so you have an idea on how you can start solving the problem. Okay, for sure, naglaban na siguro yung labi na you are encountering 2D figures, 3D figures, and then the forces are in 3D. Medyo kwan siya. Alright, so do you have questions so far? Or wala ra no? Wala na, kaya naglibog na. Okay, so let's try to go to a 2D figure, but let's make it even difficult lang, gamay, di ba? So for example, we're going to determine the resultant moment about point A of the system force shown. So 1 square is 1 feet on one side, so meaning per grid the distance is 1 foot. Okay, so as you notice, if we're going to take moments about A, and since we're not converting any moments into to another equivalent moment, so we can now take up the different moments per item. So pili na to na dobleho ng 80, so we can include them in the solution also for 100 and 100. So in the previous example, so we just took up 160 pound force as your moment, because again we're just looking for the other equivalent of the force, diba? So let's try to solve this one. So since we're going to take the resultant moment about point A, so I think this is the same concept as the previous topic. So since we have diagonals here, so the 100-pound force is not a couple with a 200-pound force. So what do we need to do here is we convert it into its corresponding horizontal and vertical components. Okay, so same goes for your 200-pound force. So we're going to look for the horizontal and the vertical component of your forces. Okay, so how do we determine this one? The horizontal and vertical components. So let's try to figure out this one first, because since this one is a difficult calculation compared to the couples. So the couples, since they are just pointing downwards, so ang 1,000 ay apili ang 1,000. So we need to resolve the 1,000 force as well. Okay, so converting it into the horizontal and vertical components. So this one is going upward, then going to the right. So since this one is a 1 meter grid na kuan on each side, so you can say that this one is 2 feet, this one is 1 feet, this one is 2 feet, 3 feet, and for the 1,000-pound force, it will become 1 feet by 1 feet, or 45 degrees. Okay, so let's try to resolve first the 100-pound force, kanisha. So if we're going to draw the FBD of this force, so this is 100 pounds, then again the distance or the slope is 1:2. So you can try to figure out the angle, but if you know how to use your ratio and proportion, so the hypotenuse of this right triangle is square root of 5, diba? I think. Diba? 1 squared plus 2 squared is equal to square root of 5. So if you want to resolve your forces, so you're going to use ratio and proportion by different triangles. So let's say this is 1, 2, 1, then square root of 5. And then the force diagram is 100 pounds. Then the horizontal and vertical components are unknown. So this one is unknown, this one is unknown. So let's say you're going to solve first the vertical component. So F, so let's designate it as F1V. So that will be the ratio and proportion. So F1V all over the hypotenuse of the force, that will be 100 pounds, is equal to, so meaning ang atbang niya, di ba? So F1V, then the 2 here, so mag-atbang sila. So they will face in the numerator. The denominator is you partner up also the hypotenuse. So that will be square root of 5. So since you can use your calculator, so you can now solve the first force, the first vertical force. So that will be 200 divided by square root of 5. So which is 40 square root of 5. So next is you're going to solve the horizontal component. So F1h. So again, F1h, the opposite side of which is the one side. So again, the concept here is ratio and proportion having similar triangles. So 1, then all over the hypotenuse of the force diagram. So 100 pounds. Then again, square root of 5. So F1h is equivalent to, that would be 100 divided by square root of 5. So that's 20 square root of 5. Okay, so if you're going to write it in the figure, so the value of the vertical force is 40 square root of 5 pounds going up. Then going to the left is 20 square root of 5. So again, it's going to the left, it's going upward because the diagonal is going to the left, up left, diba? Okay, so let's try to solve the next decomposition of forces. So solving another 100-pound force, so you can just analyze one force here because since these forces are coupled, so whatever we solve in the first force will be just equivalent to the other force, diba? Because they are a couple. So let's say we're going to solve this one. So this one is 100. And again, the slope, I mean the triangle is 1, 1. So this one should be square root of 2. Okay, so writing it in different diagrams to create a similar triangle concept. So this is 100. So let's say this one is F2V, then F2H. Then you write the other triangle. So 1, 1, and then square root of 2. So again, through ratio and proportion, we can solve your vertical force and horizontal component. So F2H. So again, the opposite side of F2H is the same side as well. So that will be 1. So all over 100, the hypotenuse, all over the hypotenuse on the other side. So this is 100 divided by square root of 2. So you have 50 square root of 2 as your horizontal component. So same goes for your vertical. So notice that the vertical side has an opposite side of 1 also. So we can say that the vertical side is the same as the horizontal calculation as well. So it's also 50 square root of 2. Alright, so again, if you try to draw the component forces in your diagram, so this becomes, so the first 1000 force, this one is going downward, then going to the left. Then the other component force is going up, then going to the right. So all forces are equal to 50 square root of 2. So lastly is your 200-pound force. So again, if we try to draw the diagram, so this one is 200. Then the triangle that you can create is 3 and 2. So by its component, so this becomes, so ato lang uspo na. So by component is, let's say this one is 200. So let's say F3V, then F3H, then this one is 200. So the triangle that you need to create also is similar to the force diagram. So 3, 2, and then this will be square root of 13. 13 squared, no? 3 squared plus 4 squared is 13. So the hypotenuse is square root of 13. So once you are done with the similar triangle concept, so we can now proceed with the ratio and proportion. So you can now have F3H first. So again, the opposite of which is the 3 side. So side to side, and then hypotenuse to hypotenuse. So that will be 200 all over the square root of 13. So for the vertical one is we have F sub 3V, then over 200, then that's 2 all over square root of 13. So F3H is equivalent to, so that will be 166.41 pounds. Then F3V will be equal to 400 divided by square root of 13. So that will be 110.94 pounds. So if we try to draw the component forces, so this is the horizontal component of the 200-pound force. Then this is the vertical component of the 200-pound force. So the value is 166.41 pounds for the horizontal. For the vertical, that's 110.94. So since we are done with the resolving of the forces, so we can now solve the moment. So let's try to write it in the upper, sa lower lang. So moment about A. So again, starting with, again, counterclockwise is positive, clockwise rotation is negative. So notice that 40 square root of 5 is in line with the point A, so meaning there's no distance, there's no perpendicular distance being covered here, so you can ignore this one, meaning it's not included. But for the 20 square root of 5, so we can utilize this. So the rotation is counterclockwise, so it's positive. So 20 square root of 5, then times 2. So perpendicular distance is 2. So next is the moment of 80. So 80, and then the distance is 1. So still a counterclockwise rotation. So this will be 80 times 1. So going to the 80 going down couple, so that will be a clockwise rotation, so it will be negative. So that will be minus 80 times 3. 80 times 3, diba? Going towards the 80, the second 80 force. Okay, so next is, let's say this component force. So the rotation is counterclockwise, so that's 50 square root of 2, and then the distance is this one. So that will be 4 feet, diba? Times 4. And then the rotation of the other force going down, so that will be clockwise, so that will be minus 50 square root of 2. Then the total distance is 4 gyapon, diba? Sakto, 4 ba? 1, 2, 3, 4. The other one is 1, 2, 3, 4. 4 gyapon siya. Okay, so next is the force on so murag kwanta murag times 3 rin siya kay should be at the point of kanang contact. So dapat na siya dire. So times 3 ra siya dapat. So times 3. Okay, so next is this force here. So this force should be at the point of contact, which is at this point. So that will be 5. So the distance of 5. So the rotation is counterclockwise still. So that will be 50 square root of 2 times 5. And the other force is minus. So that will be minus 50 square root of 2 times 4. So 4 because the distance is going towards here, kani 4. Yeah. So just try to solve this one individually lang. So the same concept as the previous topic. So lastly is your 200-pound force component. So let's try to move the 166.41 downwards because the point of action is at this point. So dire siya, di ba? So moment is minus 166.41 times 1 because the moment is clockwise. And then for the other force, the vertical force, so it's still a minus. So this will create a negative moment also. So we have 100.94 times 5. So times 5 because the distance is 5, diba? Going here. Perpendicular distance of the 110 force. Then you solve the moment. So that will be the resultant moment at point A. So medyo taas siya but wala siya ang kanang kuan jud ang iyang total nga answer. So let's try to okay, so if you have so I think the answer is this one. So just try to solve it on your own again. 650.25 pound per foot. Pound foot. Okay, so mag the same man jud siya sa previous topic but nalantay couples dire. And we take them the same as the moment as well. So different lang yung approach if you're converting it into another couple force. Okay? So I think kuan lang siguro, diha lang siguro ta so that amoy ilabad-labad sa inyong review. So again, just try to study the different forces, different topics that I have discussed, and also the assignments as well, and the problems that I discussed during the online lecture. Because wala na ang magawa sa exam, I'll be creating a different values for those examples lang. Or let's say different orientation on the forces, but you're given the same figure lang. At least you have an idea on how to solve the problem already. Okay. So again, our exam will be on next Thursday. That will be on the 25th of March. Same time, so 1:30 to 3 p.m. So most likely our exam will be will be just 3 items, since most of the basic concepts will be covered also in the advanced topics, diba? So mas mabalik-balik ta og kuan if we try to give many problems for you to solve. So muna gamay ratong i-atag lang, tulo lang kay maluwi sad ta.